So this presentation is not so much about technology, it's about you and me, the testing professional, our aspirations, our inspiration. Technology comes later, right? So if you look at this, the last 20 years or so, the IT architectures have kind of evolved tremendously, from the rise of web to rise of technologies, frameworks like Corba, to middleware, to service-oriented architecture. Now we talk about IoTs, the machines. Technologies evolved. IT architectures have evolved tremendously, creating huge complexity. On the right-hand side, you see the Amazon, the Netflix. That's a Netflix. You can read this. You can read this from there. So it's called the Death Star architecture. Very complex. You know, what are the imperatives for testing? Testers are very brave people. I don't think testers get bogged down by complexity, but the consequence of this complexity is behavioral complexity. If you look at the behavioral continuum, at the lowest end, you have the knowledge, you have the process and rule-based behavior, predictable behavior. Then you move on to more the continuum, the next stage is context and event-driven behavior. Then the data and intelligence-driven behavior, all the way up to knowledge and reasoning-driven behavior. I believe we are not reached that because the machines today cannot reason. They at best can learn from data. Now the question for testers is, testers write test cases which assume that the system behavior is process and rule-based. But systems have evolved now into context and event-based. Like a simple application, Uber application, very context-aware. A CTO of an organization which is involved in logistics and asset management told me that the systems actually automate a lot of things. The trucks get into various terminals, the terminal door opens, everything is automated. Depending on the event and context, there are 2 to the power of 15 various behavioral combinations. This is not orthogonal array problem. That is a data problem, parameter problem. How do you test this? It's no longer a coverage problem. You can't cover this. You can't even statistically figure it out, right? So what are the imperatives for testing? There you go. So the challenge for us is virtually Ethan Hunt's challenge. On top of the technical complexity, you don't have resources, you don't get time, all sorts of challenges, right? Now, what is the future? With all this challenge, what's the future of testing? Testers, our future, right? Now, I think let's move on to digress a bit about the tester's identity. I believe there's an identity crisis for testers. 4 reasons. One is we are told, testing is routine and dumb, automate and go home. Or, get a low-end resource. Testing doesn't need high-end resource. Second is, Agile and DevOps, why we need testing? And testing is one line there, selenium in the DevOps cycle. Third is, testers again have identity problem. On one hand, you are told SDET, you have to be programmer, learn programming. On the other hand, scriptless automation. You don't need to know programming. Do you learn programming or you don't learn programming? What confusion? Low end? No, you have to learn. You are high end. Right? And fourth is, you are supposed to be independent those days. TCOE, remember? Now they are saying you collaborate, you integrate. What identity do I have? In my view, we have to create our identity. Each of you have to create your identity. Let's see how. This is all about the human, not about technology. Let's understand how this can be done. How can we innovate? Inspiration. The art, the science, the craft. The art is all about synthesis. Science is all about analysis. The craft is all about practice and learning on the job. Testing is all three together. We will see how again. Right? Let's understand that innovation cannot come from within. Testers innovate, so we will automate. Innovation, if learned from within, can only be improvement, incremental improvement, right? We have to see how other industries learn from other industries and see how testing can learn from certain industries. Some examples, how this Japanese sushi restaurant created a conveyor belt for food similar to the baggage conveyor belt. Learn from a totally different industry. How this GE Medical Systems created MRI, how many of you gone through MRI? Very scary, claustrophobic, and all this sound and all that, right? Children never used to go into it. So they created a fun, like a ship going into some kind of a cave, right? So every child wants to get MRI done now, right? Learn from other industry. Or McDonald's learned from the pit stop concept, drive-through. Or many of you have kids with foldable pram, so useful. Came from totally unrelated industry, which is the aircraft, right? And this, we all know when we travel, we have these huge maps, unwieldy maps. One problem is carrying it. Second is you look like a tourist, you feel unsafe sometimes. In a safe place like London, when I was carrying a map, some joker came and snatched my map away, just like that. You don't want to, chase somebody for a map, but I lost the map. So you can crumple this map, and the learning came from branded handkerchiefs. You crumple it, don't have to fold it. You crumple it, it gets better when you crumple it. So, can we learn from other industries? Of course we can. What those industries are? Redefine. We have to redefine our purpose, our problems, our mandate. Redesign the methods so we can repurpose the whole question of testing. Testing today is defined to be test design, automation, execution, then some follow-up on defect. If that is the way it is defined, what is the innovation? We can only automate and automate more than say factory, as we will reduce cost. What innovation is possible there? Not much. DevOps karenge. Then who will do the DevOps? Identity problem. Let's create our identity, right? So testing has got a lot of definition. Googled, investigation, gathering information, experiment, questioning. Last is the most understood, well understood. Writing, automating, and executing test cases. Well understood, right? So, let's go to the real world of testing now. Now you are all warmed up into saying there is something coming up, right? Innovation, learning, inspiration. Let us build the imperatives for testing. The first imperative, what clients are telling us today. First is, you're over-engineering testing. We say we have risk-based testing. And we all know, we can debate it outside later, risk-based testing today is all about heuristics. It's not objective, subjective. And the biggest assumption, which is not always true, is that test cases are a proxy for requirements. We decide on the test case to be run based on criticality, which works. I'm not saying it doesn't work. It cannot scale. And automation, we have done a lot of automation, but clients telling me automation is not reducing cycle time. You're not thought leadership. Thought leadership is not coming. You heard of this? Thought leadership. Right? Third is, you're not giving us any advisory. Right? So the first imperative is, we have to be efficient. We have to be effective. Efficiency is running fast. Effectiveness is running in the right direction. Now we will see the next few imperatives will tell us what is this effectiveness all about. Efficiency we have learned, we all agree. We have done automation, we have done test factory, we can run, productivity has improved tremendously. We have done all that, right? But is that enough, right? Second is, quality and agility is paramount. Cost is a consequence. Don't start with the cost. Second is, testers, it's not about I'm a good tester, I'm a cheap tester, I'm a highly productive tester. How can I enable quality and agility? That is more important than saying I'm a very productive tester. Second imperative is, testing must enable directly quality and speed. Cost is a consequence. Right? This is very important. So, some insights into how, it's all about speed of change, risk of change, and the cost of change, and how testing can enable the quality of change and the speed of change. The second imperative is redefinition or redesign is, testing must enable quality and agility. Now, so far, intuitive. No serious debate. No serious disagreement. Even to the extent, what's new, Mahesh? The keynote speaker. What are you coming and telling me all this? But what I want to tell you is not about testing anymore. We'll see what it is about. Third imperative is extremely important. Let us draw some inspiration. Building security. When you come in, what does he do? He opens the boot, runs some test cases. No criteria, what is fail pass? I asked him, what have you found in the last 1 year? Nothing, sir. The dog also is very friendly dog. Wags his tail, looks at you very friendly. Testing complete. Building security has very set patterns. Police a bit more, analytical. They get in when there is a crime. A lot of it is routine, but problem solving is definitely there a bit more. Central intelligence agencies, they are much more analytical, right? They kind of collect a lot of data, analysis on where there is likely to be crime, where there can be criminals, what do we have to do to prevent crime, nab the criminals, where could those criminals be holed up? Analytical. Automation, in the conventional way, works the best in building security. Doesn't work. You get the hint? You get the hint? Second inspiration, right? How many of you watch air crash investigation in National Geographic? Don't get frightened because air travel is the most safest. I'll give you an example because it's very important. Concorde crashed. Let me tell you, all of us fly. Let this not frighten you. Air travel is very safe. You are probably worse off traveling in auto in India with that guy, who sits in a crooked way and then drives, right? Air travel is very safe. Concorde crashed. Mighty aircraft crashed. Why did it crash? There was a small rubber. How many of you know this story? Small rubber in the rubber piece, tire piece on the tarmac as it took off. The rubber piece hit the undercarriage, cutting a wire. By itself, the cutting of a wire is not a problem for a mighty aeroplane, but the wire started sparking. Not a big problem again. And for some reason, something hit the wing and the fuel started leaking. Deadly combination, fault chain. AF447 is another example of how, cockpit automation is so much today that 99.99% the plane flies itself. Rio de Janeiro to Paris, midnight, passing through intertropical convergence zone, very unstable, high, weather conditions, bad. Outside it's raining, sparkling. There are some weather conditions like Saint Elmo's fire outside, all, very ozone smell. The captain decides to go to sleep. It's called controlled rest. They are allowed. And two rookie pilots, very frightened. Suddenly, the autopilot says, I'm giving up. I can't fly this plane. Take it manually. Because the pitot tubes, which is nothing but a venturi meter, which measures the air speed, ice got into it. All the three redundant pitot tubes, the autopilot thought, I'm flying at a height and the speed is 0. This is not possible. I don't know what's happening. Give control to the pilots. Pilots couldn't handle this. They took some actions which the plane didn't understand. Unfortunate. Never happens, but it happens sometimes, right? Knight's Capital, algorithmic trading. Algorithmic trading, automated trading. Instead of one fine day, instead of buying low and selling high, they started buying high, selling low. In half a minute, they lost 440 million. Why? Because a dead code, which is normally not exercised, suddenly got triggered after an upgrade, right? And then they went broke, 440 million in half a minute. Went on trading automatically, right? Los Angeles airport, for 1 hour, they lost communication. And it was a providence that there was no air accident, all because there was a health check timer, which is raised to the power 2 to the power of 32. And after 50 days, the timer times out and says, I don't know, I can't now operate. Health check stops. The system reboots. Now, the operations people didn't know why it is rebooting, so they had a procedure that every 30 days, they will manually reboot. That particular time, they forgot. And the timer reset, health check failed, and for 1 hour, there was no communication. How systems fail? Just stay with it. Failures. The human-machine interaction, like Air 447, right? Health check. You go to a health check, they don't go and give you a report, you have 2 arms, 2 legs, and 2 eyes. They know exactly how the human body fails. Failure modeling. Treasure hunt. Testing is like a bug hunt. Treasure hunt is optimized. You have to find the treasure in a very limited time with limited resources. Inspiration. It's a bug. Bug for us, a bug is a treasure for us, right? Search and rescue. You don't go and look at the entire ocean when you want to search and rescue somebody. You have an algorithm to search. So the moral of the story is, it's about failures, signs of failures. Searching bugs, search problem, optimization problem, not a testing problem, not a testing productivity problem. Redefine the problem. You are, entering a cave, you have a lot of snakes, you have four questions. Where are those snakes likely to be? How useful is my torch? Are they snakes or snake marks? Both look same. Or are they snakes or they are snake reflections in water? In testing, where are the bugs likely to be? Second, is my test case good enough? Third, is it a bug or a symptom? Each bug can create 20 symptoms on an average. Fourth, is the bug already a duplicate? Inspiration. There you go. You derive this. This is very important for a tester. The basis for a lot of other innovations, application of machine learning, AI, everything, data mining, it is no longer about testing. It's all about the science of failures and the art, the craft, the science of provoking, searching, discovering, and localizing defects. It's not about test coverage. Sir, my test coverage is 100%. I'm sorry, it doesn't matter. I can keep covering everything and I may not find a single defect. This is in my opinion, this paves the way for extremely high amount of innovation in testing, right? Provoking, searching, discovering, and localizing. The science of failures. It's not about test automation. Test automation is important. We have a lot of articles. Why test automation fails? I'm saying it's about how automated systems fail. How can I automate the search for defects? That's more important. Redefine, redesign, and repurpose. Fault chains. How do you provoke these fault chains? It's not about testing. You can test. Login is passing. It will pass. With Agile and DevOps, the easy bugs will be detected by the developer. The critical production failures are very different. They are like Concorde. They are like Air 447. They are like Knight's Capital. Complex chain of faults. Am I equipped to unearth, to uncover these defects, or I'm still worrying about test coverage? So there are problem patterns. Today, good news is like a human body, there are problem patterns. For example, if my ESR count is very high, there is very high likely that I've got an infection in my body. The doctors will not say, I will look at your face for the next 1 month, and then I'll see what is changing, and I will, find problems. Our testing is very similar. We have to get more deeper than a general behavioral testing. We will see what and how. Understand this, testing must provoke failures. It's not about test automation, it's about provocation automation. It's not about test automation, it's not about performance testing, performance provocation, performance search and discover and localizing failures. It's about discovery automation, about localization automation, not about test automation. Okay? Which means it's not about testing productivity anymore. Defect yield per unit time and cost is more important than testing productivity. I mean, the old cop on the bicycle, or even now in their car, they go around the blocks. They're covering. They will go report. So I have covered all the areas. We have not found any thief, as though the thief will be there waiting for them. Current testing is very similar to that. Coverage. Think about it. You don't have to agree with me. We can debate outside, right? So the third imperative, the most important, is third imperative. Provoke, search, discover, localize, failure. Not testing. Next is, there is so much dissipation today in effort. In the process of finding bugs, because we are not focused on failures, we are not focused on signs of failure, there is so much wastage. Selection of test case. What is required to find the bugs? Risk-based testing, in my opinion, cannot scale. It is very subjective, right? Test case vitality. Is your test case really provoking? A lot of test cases you run, but they don't provoke. Test cases are duplicates over a period of time. Defect originates deeper below, but you're testing at a higher level, UI and API. Not enough. I know, people say API layer is better than UI. That is true. Still not enough. It is deeper below. Fault versus symptoms. Often we find a lot of symptoms. They are not really root faults. Non-issues. How many of defects? Around 30% of the defects actually are non-issues, test data related, environment related, right? Duplicate defects. So there are around 20 of these which we have done research. We have found that there is so much effort dissipation. There is a case to optimize and automate what I call the optimation. Created a new term called optimation, right? Automate, fine, but optimize and then automate, right? So fourth imperative is intelligent optimization, optimize. This is where machine learning and AI comes into picture. We don't want to use machine learning because it is cool. We want to use because there's a problem to be solved. When you map the problem properly with the existing technology, it becomes easy for us to solve the problem, right? Then there are all these functional, non-functional testing. The differentiation is actually creating problems. Because what we find is 80% of the production failures are actually non-functional issues. Non-functional doesn't mean performance only. Scalability, stability, reliability, resilience, fault recovery, error handling. There are hundreds of them, but they masquerade as functional defects. But what we have done? Functional, non-functional. Functional first, non-functional later. Okay, we do engineering, and they're actually called quality attributes, not non-functional attributes. The Carnegie Mellon term for non-functional attributes is quality attributes. And quality attributes, which is non-functional aspects related to architectural quality. Very few defects are because of the UI problem or business process problem. So architectural quality is the key. Now you know where I'm heading at. So if you keep testing at the business process testing, you will have diminishing returns. If you define that defect per unit time, defect per test case is paramount, then you test at a business process level, you can have hundreds and thousands of business process tests, you will not get the returns. Architectural driven testing, right? Architecture quality. Next, many dashboards, most of them that we see are rear view mirror dashboards. Productivity, we found so many problems, they executed so many test cases. But the inspiration comes from the cockpit again. The cockpit concept is called the dark cockpit. It only gives what is relevant for the plane to proceed. So, can we create certain visualizations, not just metrics, which are rear view mirror? What happened? Not important. What is happening? Where the system is likely to fail? Where there are likely to be defects? Why are they happening? What is required to, like a radar? So you have the sixth important imperative is visualizations, right? How do we realize this? A test case typically, we execute test case, and the result of a test case is typically what? Pass or fail. Beyond the point, you can't innovate. A test case is like a probe, like a stethoscope. And a stethoscope, doctor doesn't say pass or fail. There is a bit of a monitoring there. So you can do a lot with the test case. Is it only pass, fail? You can monitor, you can diagnose, you can investigate, you can simulate, you can prognose, you can mine data, you can, of course, say pass, fail. Exploratory testing, I'm just kind of putting a big, nice terms around it. So a test case is like a probe into the system. How are we using the test case? Much more intelligently than saying, sir, it passed, it failed. You can't innovate here, right? So 4 pillars, purposeful automation. Automation is not about automation or 80%, 90% automation. Automation is about, is it finding defects? Purposeful. Architectural driven testing, right? Visualization. Of course, visualization and analytics come closely together, right? 4 pillars. We say test deliverable is test case. No, that's my tool. When I create a test case, it is not a deliverable to the customer. It is my tool. Deliverable actually could be all these deliverables. Very insightful, something that helps quality, improve speed. Not about my testing, right? So the new age tester is all about huge opportunity for the tester today. You want to call it quality engineering, please call it. You want to call it tester, please call it. You want to call it quality control, call it. Tester can be a data analyst, tester can be an automation expert, tester can be a domain expert, tester can be a business analyst, tester can be an optimizer, See, testing is the only field where you can reverse things, You can say, I am doing data testing, machine analytics testing, or I can say, I'm using machine learning in testing, AI testing, and testing in AI. So you can do both. So there is a huge opportunity for testers to innovate, to get inspired, and play the role, the centerpiece of IT. We have done a lot of shift left. For you, this is left, right? We have now said, no, we have everybody shifting left, so we can't, nothing left on the left, so, right? Then we say shifting right. For some time, they say shifting right is not right. But there is no go, no? We have already shifted left. No, we shift right. Now, some are saying shift up. Okay, they're all words. Let's understand what do we mean by all these words. Let's bring more engineering into testing, not just process, more engineering, more rigor, more brains, more insights, more technology, more art. Art is all about synthesis, science is all about analysis, and craft is all about hands-on learning as you go, right? Change the conversations. Rather than say that, I am executing hundreds of test cases. With this, you can change the conversation. There's no need. Somebody says, I will do testing, I don't need you. You can say, okay, I know all this, leave the card, leave the room, they'll call you. Because you are capable of doing all this. I'm capable of doing all this. Change the conversations. Right? Bring more insights, analysis, analytics, knowledge into it. And to sum it up, inspirations from other fields, science of failures, knowledge of failures, architectural knowledge, more engineering, new thinking, new technology. And the new tester will be at the centerpiece of IT delivery.
Thank you, Mahesh.
Thank you, and if there is, we can always meet out and questions.
Yes, that's lovely. I would love to invite, Mr. Gaiarelli, to hand over a small token of appreciation from us. You could be on the dais. On the dais. So it was a very insightful talk, talking about being a forensic scientist with very much to be a Sherlock Holmes in the software development world. And really thank you, Mahesh, for helping us with the inspirations and the aspirations. So, great. So now we have the next speaker, and I'm very glad to introduce Meenal. And Meenal is going to speak about the evolving role of digital quality and disruptive technologies, and how should we really develop a discipline of digital quality. And to introduce Meenal, Meenal is the Office Managing Director for Deloitte's US India Mumbai office, and serving on the Executive Council of Deloitte US's India office. She is also a dynamic woman leader, known very well within Deloitte and in the industry for her invaluable inputs, subject matter expertise, knowledge, leadership, and consulting skills. Meenal is leading and managing the Deloitte's US Mumbai office successfully. She's been a very strategic member, resulting in the growth, new business offerings, and development of client relationships. She has been also involved with developing the employee capability initiatives and also engagement initiatives, and she has built eminence and came up with various innovative approaches for growth, for the testing team. Meenal is regarded as a very active, dynamic, and result-oriented managing director, and she's currently also looking at the competency development, and her key responsibilities include leading and supporting sales pursuits. Above all, Meenal has been a great supporter of the STC conference right from the time we started the regional rounds as an idea. In fact, Meenal was one of the contributors for us to think about doing a regional rounds, and Deloitte supports us with hosting these regional rounds in Mumbai in their office, where she personally attends all these paper presentations and also sees and coaches and mentors a number of the paper presenters. So, Meenal, yes, okay. So, Meenal, all yours, and we would love to hear you and your thoughts on the same. Okay, a small round of applause, gentlemen. Yes.